Imagine an alien world, a scorched barren landscape hot enough to boil water when mysterious holes the battle-scarred surface revealed a ladder in the climbing tongs. Each fight enough to house the city. This world is there and yet it breathes life into its nearest planetary neighbor. This extraterrestrial place is closer than you might imagine. This is our moon. Look at our solar system from an alien visitor's perspective. What would surprise you? What would make you look twice? The unlikely answer, our oversized moon. If you look at our moon and compare it to all of the other moons in our solar system, it's actually quite odd. It's huge, way bigger than any other moon in the solar system. Compared to its planet, it's a giant moon. It's almost like we're a binary planet, two objects orbiting around each other to some degree. Our planet-sized moon is unique in the solar system, and this battle-scarred giant serves as our guardian angel. Its vast gravity raises the tides that breathe life into Earth's oceans. The moon stabilizes the tilts of our planet, regulating the climates and seasons. Without the moon, humans may never have evolved. We owe everything to our moon, yet its formation is one of the greatest unsolved mysteries in planetary science. There are many ideas for the origin of our supersized moon, but they all start the same way, with the formation of the inner solar system 4.6 billion years ago. When the solar system first formed, it would look very different from the way it looks now. Instead of having a few planets and mostly empty space surrounding the sun, you would have had a disk. And this disk would have been thick. It would have been composed of gas, dust, and rocky bodies. The infant sun sparks into life, blowing away the clouds of gas that are closest to it. The rocky fragments that are left behind clump together over time to form planets like Earth. But there are many more of these planets than we see today. Giant rocks jostle for position, crossing paths as they struggle to find stable orbits. Is it possible that one of these planets was destined to become our moon? There have been a lot of ideas about where our oversized moon came from. It was just that we wandering around in our solar system and we captured it. According to the capture theory, a wayward planet passes a little too close to the early Earth, and our planet's immense gravity captures hold of it. The planet settles into orbit around the Earth, and it becomes the moon we see today. This theory seemed to check all the boxes, but scientists needed proof that was right. If it was really true that the moon was a captured planet, you would expect that its constituents would be different than the Earth. It was something that formed in a different place in the Earth, and then got captured, so you would expect them to be made of different stuff. To prove the theory, scientists needed to compare the moon's earliest rocks with similar examples found on Earth. The best rock for comparison is a mineral that could have only been formed when the newly born moon was still molten. On Earth, this type of rock is formed in highly volcanic places like Iceland. This is what we want. You see this anorthosite? How white it is. Anorthosite forms in a different way than normal basalt. You can almost think of it like the white foam on the head of a dark beer, sort of floating up to the top. So in a magma environment, this would form and then just float up to the top of a magma sea. Getting a sample of anorthosite from the moon is important because darker rocks could have had their chemistry altered by asteroid impacts. We really had to have a piece of this anorthosite rock because we just couldn't learn about the origin of the moon from the dark materials. We had to have, that Genesis rock. In the 1970s, Apollo astronauts collected samples and brought them back to Earth for comparison. The results shocked the scientific world. What they found was that the composition of the moon was almost exactly the same as the composition of the crust of the Earth. So this idea that the moon was a captured planet from elsewhere in the solar system was out. There was no way that was true. The rocks looked very Earth-like in many respects, and that was a puzzle with the captured planet theory blown out of the water. Planetary scientists took action. Scientists said, "Look, we've got to get together and figure this out," and they went to a conference together in Kona, Hawaii, all the top scientists in planetary science, and they hammered out all of the leading ideas. A lot of people think scientists don't have an imagination. We're just robots looking at things and analyzing. It's not like that. If you want to figure out how something like the moon came to be, you have to have a wild imagination and try all these crazy ideas, but they have to be constrained by reality. They locked themselves into a room together and emerged from that meeting and said, yes, this can work. The new theory focused on the water contents of the moon rocks. They were surprisingly dry. Something must have heated up the moon to unimaginable temperatures, and we were led to think that it must be some sort of coalition. The new theory was built around the idea of a catastrophic collision 4.5 billion years ago, but it wasn't an impact into the moon, it was an impact into the Earth. There was a crazy idea that the Earth formed, and while it was still young, another planet-sized object, something about the size of Mars, came in and hit the Earth, blew off a huge amount of material which then coalesced and formed the moon. This is a pretty cool idea, was groundbreaking, I guess, literally. Scientists named the Mars-sized planet Theia, and they modeled how the impact would have played out 4.5 billion years ago. Theia catches the Earth with a glancing blow. The impact propels molten debris bar into space, forming a ring of burning rock around the Earth. If we could travel back in time and somehow stand on the surface of the Earth when the moon was warming, it would have been amazing. A bright ring of fire was stretching across the sky, and here in the sky would have been a bright ball of magma, glowing with all kinds of shrapnel and small rocks being attracted to that point because of the immense gravity. This was the proto-moon, the thing that would eventually become the moon we have in our sky today. Our moon forms in under a year. Its crust is almost chemically identical to the Earth's because they share a common origin. This impact idea, as weird as it sounds, actually does the best job explaining everything that we see about the moon. The impact hypothesis becomes the leading theory for the origin of our oversized moon, but when space probes journey to the far side of the moon, they find something that throws the theory into chaos. Our moon has a dark secret. It was born with a twin. Take a look at the moon tonight and you might see a familiar face, or maybe a rabbit or a tree depending on your culture. Myths and legends surround the patterns etched on the surface of the moon, but what can these marks tell us about the riddle of our oversized guardian? What we call the man in the moon is actually just a series of light and dark patches on the moon's surface, and of course, people are programmed to recognize faces everywhere, so that's why we see this pseudo-face. These dark patches appear to be unique to the moon. Centuries ago, astronomers thought they were seeing enormous oceans of liquid water. We now know the dark stains are actually ancient floods of volcanic lava. Planetary geologist Yanni Rada takes a bird's-eye view of similar features on Hawaii using her research kite camp. These lava flows we're standing on are identical to the things we would see if we were standing on the dark patches of the moon. They are dark in color, they're made of basalt, and they flowed out in vast lava flows across the surface. It turns out the dark plains of lava on the moon are battle scars, evidence of a violent past. 4 billion years ago, asteroids rained down on the newly formed moon, tearing into the surface where the fractured crust is thinnest. Molten lava seeps from the moon's hot interior, spreads out in giant pools, solidifies, forming the scars we see today from Earth. And strangely, although the moon rotates, the Earth's gravity holds on to it so tightly the same face points towards us at all times, making the features on the far side of the moon a complete mystery. For all of history, the far side of the moon was invisible to the Earth. It's the backside, you can't see it. In 1959, Soviet spacecraft Luna 3 flies past the moon's far side and photographs it for the first time. Astronomers expect to see the familiar dark and light patches. They were in for a big surprise. When scientists saw the pictures, they were shocked. The far side looked completely different than the near side. It's saturated with craters. It just was such a huge dichotomy. Nobody was expecting that at all. The far side still had massive impact craters, but it was uniformly pale. It seemed like no dark lava had bled out onto the surface at all. But why? The only solution we could come up with is there's a difference in thickness between the crust of the near side and across to the far side. The back side must be so thick that lavas are not able to come up through them and erupt out onto the surface. Instead, on the front side, where it's very thin, lavas can easily come up through cracks and flow out onto the surface. Recent NASA missions confirm the crust on the back of the moon is around 30 miles thicker than the crust on the front. The far side is thicker. It's not like, oh, part of it is and part of it isn't. No, it's really the other side of the moon has a thicker crust than the near side. That's bizarre. So one of the biggest mysteries in planetary science over the last about 50 years is, why is the crust to the far side so thick? The impact theory doesn't really cover that. It just forms the moon, but it doesn't say why one side should be so different than the other one unless something strange happened. The new age of supercomputers brings about the first credible explanation. The impact of Theia could have made two movements on one, and this double birth might also explain our double-sided LU. According to the theory, 4.5 billion years ago, there are two moons in the night sky. The smaller moon chases its larger sibling, gradually getting closer. Eventually, the two moons mush together in slow motion, and the smaller moon covers the far side of the larger moon, creating a new much thicker crust. Not all impacts are high-speed superviolent events that eject material everywhere instead of just smacking into it. It would have just merged with it, just been pulled apart and smeared out over the moon. Essentially, when you look at one half of the moon you see more of one body, and we look at the other side of the moon you see more of the other body. They kind of wrapped around the first body, and so it's thicker on that side. Eventually, the two moons mush together in slow motion, and the smaller moon covers the far side of the larger moon, creating a new much thicker crust. Not all impacts are high speeds, superviolent events that eject material everywhere. Instead of just smacking into it, it would have just merged with it, just been pulled apart and smeared out over the moon. Essentially, when you look at one half of the moon you see more of one body, and we look at the other side of the moon you see more of the other body. They kind of wrapped around the first body, and so it's thicker on that side. Two moons become one. The evidence for this cosmic collision is stacking up, at least inside supercomputers, but not all astronomers are convinced. They search the heavens with different solutions, and they finally find it on an alien planet that's being broiled alive. 480 light-years from our solar system, a rocky Earth-like planet orbits a sun-like star, but this is no place for life. CoRoS 7b is a sungrazer. This bizarre exoplanet orbits its star 60 times closer than the Earth does to the Sun. This close proximity locks one face of the planet to its fiery companion, just like the Moon is locked to the Earth, the result of cosmic barbecue. Temperatures soared over 3,000 degrees Fahrenheit on the near side of the planet, reducing the rocky surface to a boiling ocean of liquid magma. In contrast, the shaded far side of the planet has a cool and solid crust. This overcooked exoplanet is the inspiration for a surprising new theory about the formation of our Moon's lopsided crust. The idea comes from a pair of young researchers with no background in lunar science. Because I work in exoplanets, I knew very little about lunar geology when this whole thing started in 2011, Jason Wright says. He discusses sun-grazing exoplanets with colleagues when the conversation turns to the mystery of the Moon's half-and-half crust. And then I remembered that the Moon, when it formed, was very close to the Earth, and the Earth would have been extremely hot after the impact that formed the Moon, he adds. In fact, the geometry is almost exactly the same as the CoRoS 7b system. That got me thinking, well, maybe something similar happened to the Moon. Jason theorizes that the hot Earth cooked the near side of the Moon just like sun-grazing planets are cooked by their stars. So if you imagine that the Moon is forming this big hot ball of the Earth hanging in its sky, on the far side of the Moon it would be quite cool, he explains. The near side of the Moon is kept hot by the molten Earth. Vast clouds of mineral vapor stream from the hot surface, feeding a cloud that surrounds the Moon. On the cool side, these minerals condense, rain down, building a thicker crust. It's a neat idea, but it only works if the Moon locks one face to the Earth right after it forms. Jason asks grad student operative Roy to see if that's even possible. When Jason first came to me with the idea, he was very excited about it, and he believed it was a big deal, Roy says. The calculation to check the tidal locking of the Moon was pretty easy to do. The number was so small that we were surprised. It was on the order of 100 days, which is very, very quick in astronomical timescales. After this breakthrough means that the near side of the moon locked to the Earth while our planet was still molten, supporting Jason's theory of a cooked moon. It's still very new, but the theory has legs in science. If you have two ideas that explain something equally well, you kind of want to go with the one that has more natural outcome, Jason says. This broiling Earth idea is a natural outcome of what we know must have happened. Thankfully for us, the surface of the Earth is a lot cooler today, but the inside is still hot, thanks to the radioactive decay of metals deep inside the core of the Earth. If this rising heat drives the Falcon ISM and the geological activity we see on the surface today, there are mountain ranges being pushed up and other mountain ranges being subducted into the ocean. The crust of the Earth is continuously changing. The moon doesn't have a radioactive core, so scientists have always assumed that its center is cold and its geology dead. But a series of unexplained observations suggest that once again, we're wrong about the blue. One of the big questions we've been trying to answer over the last few decades is there any activity on the moon left at all? One scientist asks. For hundreds of years, astronomers have reported strange bursts of lights coming from the moon. Others have witnessed reddish glows that lasted for minutes at a time. Could these rare sightings show that the moon's geological heart is still beating? The moon is small enough that over 4 billion years it should have cooled all the way through, and yet there's still some things that we see that may be kind of sore to indicate that there's still stuff going on inside of it, another scientist explains. Aristarchus, a volcanic region in the northwest of the moon's near side, is a hotspot for the weird sightings. Astronomers have reported over 700 glowing lights here in the last 50 years, even Neil Armstrong saw something strange from the window of the Apollo 11. Subsurface now as an area there that is considerably more illuminated, that's around be quite a lot of for efforts to it, light bright, Neil Armstrong radioed back to Earth. So what's going on? The smoking flanks of volcanoes give planetary scientists an idea because where there's smoke, there should be fire, one scientist says. How these events are happening on the moon is where they're found. They're actually found in a very special location on the moon, and it's very much like what we're standing on right now. Aristarchus is covered in vast floods of volcanic ash, and some scientists believe this fine light material is responsible for the strange sights we see from Earth. Now the kind of ash that I'm holding right here is a little bit damp because there's been. As we progress from single-celled simple organisms to much more complex organisms, greater stability really helps. How different would things have been without the moon? Just look at Mars to see the devastating effects of an unstable tilt. Mars actually had a tilt as far as 60 degrees, that means it was cold at the equator on Mars and warmer at the poles. That's really a difficult environment for life to arise and grow. When we look at Mars, we see that its axial tilt swung around to such a degree that it inhibited life. If the Earth had swung that chaotically, ice ages would have come and gone like seasons. Life would have needed to start from scratch over and over, not having time to evolve into complex organisms. Mars serves as an indicator that our supersized moon was instrumental in the development of intelligent life on Earth. Increasingly, scientists believe similar cosmic partnerships are the key to finding other intelligent life in the universe. When we're looking at exoplanets and we're wondering which one of these could have civilizations, advanced life forms, and there's a bunch that had a big moon and a bunch that didn't, well, I would say let's first look at the ones with a moon, one scientist suggests. If for no other reason, we know that on this world we have a big moon and we have advanced life. As we're looking out beyond our solar system, looking for exoplanets that might be habitable, maybe we should be looking for an object that has a supersized moon in the right location around its star. It just might be the perfect place to look for life. If we ever want to see these distant exoplanets up close, we'll need a cheap, reliable route into space, and the moon could be the key to unlocking this journey to the stars. Futurists believe mankind's destiny is to conquer space. Surprisingly, the moon may be the key to making these dreams a reality. A lunar launch pad has so little of the atmosphere and gravity that make Earth launches so challenging. Establishing a base on the moon, for example, would require very little energy to get off of the moon and to explore other bodies from there. Yet another obstacle to long-term survival on the moon are the radical temperature swings. One of the things we don't always think about the air around us is it actually redistributes heat, one expert explains. On the moon, you have no air. So if you have your hand and half of it is in sunlight and half in shadow, you've got a 400-degree difference there. The best protection from all these long-term problems is a thick layer of rock. But a recent discovery suggests future astronauts won't need to dig to build their shelters underground. This remarkable hole on the surface of the moon called a skylight is the size of a football field, an expert explains. We are seeing big openings to massive cave systems that might form the perfect base for lunar exploration. Skylights are the entrances to a network of vast tunnels which likely run for miles under the surface of the moon. There are already underground caverns there, and they're not carved by water, these are carved by lava. Similar tunnels, called lava tubes, exist on Earth in volcanic regions like Iceland. So we're in the bottom of a hole that's formed from a collapsed lava tube, an expert describes. Now we know that on the surface of the moon, there are holes like this, and if all indications are correct, they also lead to giant lava tubes just like this one. Lava tubes form when flowing rivers of molten rock start to cool, the surface solidifies first, insulating the hot lava below that continues to flow, carving out long underground houses. Living in a tube like this actually wouldn't be that crazy, an expert remarks. In fact, this is a big tube, it's quite large. But you know, the ones on the moon are 10 times bigger than this. On the moon, lava tubes run below hundreds of feet of solid rock, protecting the tunnels from radiation, micrometeorites, and keeping the temperature stable. A lava tube like this on the moon would be nice and stable, and perhaps never get much colder than the coldest caves on Earth. Astronauts on the moon could seal themselves inside these tubes by adding airlocks. If we were able to colonize a lava tube under the lunar surface, we could actually adjust the environment, an expert says. We could pump in air, we could make the temperature right. You could actually get out and walk around in this vast subterranean tunnel, an entire city down there. Scientists think these lunar space stations could be self-sufficient. There are craters that are always shaded, and they contain water ice, an expert explains. And so that is really exciting because we didn't realize that there was actually still water on the moon. We thought the moon was just bone dry for many years. That was the main trip. And now we're finding out that contained in soil, contained inside of crater walls that are permanently shadowed, there is lots and lots of water ice. Water is the perfect resource for a lunar launch pad, as well as drinking it. You can split water with electricity to create oxygen to breathe and hydrogen to use as fuel. The moon's craters hold around 6 billion tons of water ice, enough to launch 20 rockets into space every day for over 100 years. For over 4 billion years, the moon has driven our revolution, shaped our climate, and in the future, its resources will allow us to conquer space. But it's not going to be around forever. Scientists have mapped out the depth of the moon, and it's going to be brutal. For over 4 billion years, the Earth and the moon have traced the delicate dance around the sun. But our celestial partner is gradually slipping away. Sometimes we talk about things that are reliable, we say there's nothing as reliable as the rising of the sun, right? We can think of the moon in the same way. It goes through its phases, it stays there, night after night, year after year. But it turns out the moon is actually moving away from the Earth, and that's